Good morning, everyone. I'm Subhada KAR and GATE SRF at CSI NML and a PhD scholar at ACSIR. Today, I'm going to talk about compositionally complex alloy system, alloy design, and related concepts. But first, let's take a look at the brief history of materials. We can see that in the history of mankind, material science has been a really important subject, such as Stone Age, Bronze Age, Iron Age. We all used materials in those periods and we are still using them today. However, the age of steel was revolutionary. And we can see how the speed has taken up in the study of material science. However, in those days, the alloy design was restricted to the use of one or two principal elements. However, post 2000, with the birth of high entropy alloys, the alloy design shifted towards the center of the phase diagram and we started using multiple principal elements. So, what are high entropy alloys exactly? Now, as I said before, so high entropy alloys came into existence because people wanted to explore the center of the phase diagram. And Ye et al. Came to a conclusion that in contrast to what they expected, that there should be multiple intermetallics forming if they mix all the elements together in equiatomic ratio, they found a single phase solid solution. So they attributed this feature to the high entropy, and they said that the entropy maximization is actually suppressing the effect of the enthalpy. So they rendered some really good properties, and the four core effects were rendered responsible for obtaining such properties. Now, however, when they started, it was limited to the single phase solid solutions, but people discovered that if we limit ourselves to the single phase solid solutions, we will be limiting the strengthening mechanisms as well as the strain hardening ability of the material. So people with time discovered that it's not just the entropy that is determining the single phase solid solution, and we have other parameters that also affect the phase stability of the material. So people started working on non-equiatomic alloys, non-equiatomic compositions, and they discovered that there are many more strengthening mechanisms that can be introduced, and also the strain hardening ability can be increased a lot. Now, there is an interesting study of Wang and Huang who stated that are superalloys a subset in the set of HEAs, because many of the superalloys exhibit the mixing enthalpy, atomic size difference, as well as the configurational entropy in the range of high entropy alloys. So, before amalgamating both the ideas, let's go through the third concept, that is HDI strengthening, heterogeneous deformation induced strengthening. Now, what is that? It is designing the heterogeneous microstructure in such a way that we can achieve a better combination of strength and ductility. So, I'm now trying to combine the three ideas. We know that existing superalloys have been a result of hard-earned experience and innumerable experiments. However, the scope of improvement lies heavily in a good composition design and better microstructure control. So with the introduction of HEAs, we now know that we have a huge compositional space to play with. And with proper thermodynamics and kinetic study, we can reduce time and cost for alloy design. And with the introduction of HDI strengthening, we can get better strength ductility synergy. So the summary of the presentation is to incorporate HDI strengthening in multi-component alloy systems such that we can mimic the microstructure of superalloys and develop new materials with the compositional space provided by high entropy alloys. Now I would like to end the presentation with a forward to exploratory high temperature research by W.E. Ruler, where they said that in early World War II, with planes flying higher and faster, they were faced with the job of producing quickly alloys that possessed high strength, and they worked in a temperature range that was not previously considered before. However, they greatly wished that if they had time someday, they would like to properly study the alloy design and have a more logical approach towards the alloy design rather than trial and error. Now that the age of war is over and we are in a peaceful time, it is upon us, the budding researchers, to make his dream come true with a proper alloy design by understanding the mechanisms and a good thermodynamic and kinetic approach. Thank you.